Introduction to force and acceleration. When an object moves, changes, its position or falls all come as a result of force acting on them. They all have a change in velocity per unit time. In this video, we are going to be talking about the relationship between force and acceleration. If you have ever flown in an aeroplane, you will know how the back of the seat pushes you forwards when the aeroplane accelerates down the runway. The pilot must control many forces on the aeroplane to ensure a successful takeoff. For a body of constant mass, its acceleration is directly proportional to the resultant force applied to it. Both force and acceleration are vector quantities. That means when describing them, you include both their magnitude and direction. Isaac Newton developed the second law of motion by synthesizing the experimental work of his predecessors, specifically Galileo Galilei, Christian Huygens, and Johannes Kepler, combined with his own work on calculus and gravity during the 1660s. He officially presented these laws in his 1686 work. The equation also shows that the acceleration produced by a force depends on the mass of the object. The mass of an object is a measure of its inertia, or its ability to resist any change in its motion. The greater the mass, the smaller the acceleration which results. If you push your hardest against a small car, which has a small mass, you will have a greater effect than if you push against a more massive car. So, for a constant force, the acceleration is inversely proportional to the mass, the pull of gravity. Now we need to consider some specific forces, such as weight and friction. When Isaac Newton was confined to his rural home to avoid the plague which was rampant in other parts of England, he is said to have noticed an apple fall to the ground. From this, he developed his theory of gravity, which relates the motion of falling objects here on Earth to the motion of the moon around the Earth and the planets around the sun. The force which caused the apple to accelerate was the pull of the Earth's gravity. Another name for this force is the weight of the apple. The force is shown as an arrow pulling vertically downwards on the apple. It is usual to show the arrow coming from the center of the apple, its center of gravity. The center of gravity of an object is defined as the point where its entire weight appears to act. Large and small objects. A large rock has a greater weight than a small rock, but if you push both rocks over a cliff at the same time, they will fall at the same rate. In other words, they have the same acceleration, regardless of their mass. This is a surprising result. Common sense may suggest that a heavier object will fall faster than a lighter one. It is said that Galileo dropped a large cannonball and a small cannonball from the top of the Leaning Tower of Pisa in Italy and showed that they landed simultaneously. He may never actually have done this, but the story illustrates that the result is not intuitively obvious. If everyone thought that the two cannonballs would accelerate at the same rate, there would not have been any experiment or story. In fact, we are used to lighter objects falling more slowly than heavy ones. A feather drifts down to the floor while a stone falls quickly. However, we are being misled by the presence of air resistance. The force of air resistance has a large effect on the falling feather and almost no effect on the falling stone. When astronauts visited the moon, where there is virtually no atmosphere and so no air resistance, they were able to show that a feather and a stone fell side by side to the ground, an object falling freely.